Hi, my name is Christopher Fornicero, and this is my Physics Lab 2, Motion of a Falling Object. Here's a brief table of content for what will be covered. Purpose, formulas, tracker, glow script, part 2, comparison, final questions, and conclusion. Purpose. The purpose of this lab was to create an experiment where we could observe an object affected by both gravity and drag force and their effect on velocity. Then we would compare a computational model with the observed model using two graphs, one from Tracker and one from GlowScript. Formulas. Some of the formulas we used were the velocity update formula to help calculate the speed of the ball at various time frames, position update to calculate the position of the ball with a changing velocity, F equals mg for gravity, one of our forces, and then drag force, our other force, which we would be needed when we found our proportionality constant later on. Tracker. For this, our group threw a paper ball weighing approximately 3.5 grams. I then inputted this into Tracker along with standardized units of measurement, or a meter stick, and finally I tracked the ball every 0.033 seconds. Then Tracker returned our data set to the right of the video, giving us our x and y coordinates over time. Next, for GlowScript, I took the initial velocity in both x and y directions when the ball was released from the hand on Tracker, and then used that for initial speed, followed by inputting our Fnet, which was gravity, or 9.8 meters a second squared, multiplied with our mass, 3.5 grams. Finally, inputting our previous velocity and position update equations, GlowScript could then model the flight path of our object. The next graph was the same thing, however this time with drag. So to do this, we had to find the proportionality constant b and then input that into our drag force equation. Afterwards, all that was needed was to add it with our force of gravity to find Fnet, where the rest of our equations could remain the same, thus resulting in a similar but slightly different graph. Finally, looking at these graphs side by side, they're very similar. However, there's slight deviations, especially towards the end. This can mostly be attributed to the human error of the initial throw and how when starting at the origin, there was a force acting up on the paper before it was fully released sometime past the origin. Overall, however, you can see they're fairly similar. Final questions. Does the model demonstrate terminal velocity? In this case, it does not, because terminal velocity is only achieved when drag equals gravity as they are balanced, so we have no net force, thus a constant velocity at terminal velocity. However, our object never reaches a constant velocity, so therefore it does not demonstrate terminal velocity. And if thrown directly vertical, would it take longer for the object to reach the ground with the same initial speed? The answer in short is yes. This is because our initial speed was at an angle where some went to our y velocity and some went to our x velocity. However, if it was all in the y direction, our initial speed would be greater, and using the position update formula, we can reverse engineer to solve for time, which would be larger than our velocity with an angle. In conclusion, this lab helped demonstrate the effects of drag and gravity on an object, helped explain both of their relationships with falling objects. Thank you.